All right, I don't know what that is. It just made me laugh. So anyway, so lesson 14 here. We are computing actual lengths from the scale drawing. So the idea here is they're going to give us the scale drawing, and we've got to pull out the information from it. So we're going to talk about here that here the distance around the entire boat is 28 4/10 units. So in other words, the perimeter there when it comes down to it. But a lot of times we don't use that word perimeter when we have a curved shape, so that's why we can get away with it. So the larger figure is a scale drawing of the small one. So the larger figures, so this guy is the scale drawing, which makes this guy the original that we're looking at. And again, that's important regarding when we set it up to find out our scale factor. So state the scale factor as a percent, and then use the scale factor to find the distance around the scale drawing. Okay, so what we can do is as long as we match up, we can grab whatever distance we want. I could grab this entire line. I could grab this entire line. I'm not going to grab anyone that's on a diagonal, so I'm just going to count how far is it from here, and I'm going to use that particular point. Take a moment, count up those spaces. Yeah, there's 4 of them there. And then if we count from this point, I got to do the corresponding, so I got to go right to there. If you go and count those guys out, you're going to get yourself 11 units. Now, this is important because now I can go ahead and figure out my scale factor. So this is the original amount, so that's why it's in the denominator. That's my scale amount or my new amount, so that's in my numerator. So when we do this, we get 2 7500ths. Now, they were very clear. They want my scale factor as a percent, so instead of 2 7500ths, I'm going to say... yes, 275%. Again, 2 spots to the right, times it by 100, however you want to look at it. So this is an enlargement, so 275% of it. So if the perimeter is 28 4/10, and it's a 275% of it, so we can just multiply. All right, can reach for your calculator, type in the 28 4/10, times it by the 2 7500ths, which makes it kind of silly to change it into the percent because we're going right back to, anyway, 78 1/10. Yeah, and again, units they're just saying there. All right, so figure out the scale factor and then use the scale factor. We can do that with perimeter. We're going to see that area does something different, but with perimeter, because it's one-dimensional, we can just multiply and be done with it. All right, so the very next problem that we're looking at, very similar here, where they're telling the length of the longer path is 32 4/10. The shorter path is a scale drawing. So this is our scale drawing. This is our actual that we are dealing with. So again, important because it lets me know numerator and denominator. I'm just going to count from here to there, which will correspond with this to that. So if we go and count, that's 6 units. That's 2 units. Now, since this is the actual, goes in the denominator, the scale in the numerator, so it's 1/3. Now, I don't really want to change it to anything. It says find the length of the short explained. So it doesn't say I need to change it to a percent. My scale factor is 1/3. Leave it as a third. Change it if you want to, but there's no need for it. I'm going to multiply my 1/3 times my 32 4/10, since that is the perimeter, or the length of it, I should say. And we'll multiply. So I got decimals playing with fractions, so I don't want to change that to a decimal because it's a repeating decimal. So we're going to change everything into fractions. If we say this 32 4/10, there's my 32 4/10 that I've got. So I can use it. I can simplify, change it to improper fractions, all those things. I can also make use of my calculator as well, my fraction button. Remember your ABC button. So if you'd like to do that, there's nothing wrong with that. What you're going to figure out here is you're going to get 10 8/10 as a decimal. If you multiply it out, you would get 10 4/5. So again, I don't mind us using the calculator here. We're going to kind of use this feature. We'll get back away from the calculator as we move forward, but for right now, it is a welcome participant. Remember, you can use that A, B, C button to help you write fractions in. Otherwise, just go old school. The very next problem that we've got, we're actually going to save for tomorrow in class. We might not get to it in class tomorrow, but that's what the plan is. So let's actually move forward, and let's go on to example number 3. Okay, so I know the printing got a little bit small here on it. So here we go. We got erase card number 2 is the scale drawing. So this is important here. So that is my scale drawing, which makes this the original. All right. The measurement from the front card to the back card is okay, so 12 feet. There it is. While the measurement from the front, okay, there it is, the 39 feet. The height of the car is 4 feet. Okay. Find the scale factor and write an equation. Explain what each part of the equation represents in the solution. Okay, so find the scale factor. They didn't tell me percent or decimal, so I'm just gonna leave it as I have it, because if I'm going to use it, I got to get it out of the percent form anyway. So that's my scale. That's my original. So I should be putting my 39 over the 4, right? No. Remember, this is the horizontal, so I got to use this horizontal distance as well too. So it should be a 39 over 12. When we go ahead and divide, we do get 3 and 25/100ths. Again, it could change to 325%, but there's no need for that. That's not going to help me out. And since it's 4 feet and the scale factor, yeah, you're just multiplying there. So 4 times 3 and 25/100ths gives you... Oh, okay. Gives you 13. All right. Oh, man. Kind of expected the decimal there almost, right? No. All right. So, yeah, so it's 13 units of measurement. Yeah, 13 feet that we've got. Now, so we found the scale factor. We wrote an equation as in that showing your work for it. Explain what each part of the equation represents. So the big thing here is I'm finding the percent of this amount. So I'm finding 325% of 4. Again, that's why it's getting to be a larger amount. Let's go down to the last one that we've got. What? No. It's going to be okay. No. All right. Why don't you try it? Pause it, and see what you can do regarding it. They are asking for you to determine the scale factor. So write an equation, so show work, all right, and then relating they want the vertical heights, all right, so pause it for a second. Yeah, I'm back. I wouldn't leave you there. All right. So scale factor here. So drawing 1, drawing 2. They didn't really tell me who's the original, but if we're going to do a little bit of common sense, what comes first, 1 or 2? Yeah, okay. So it is drawing 1. That is our original that we are looking at. So that's why we'll have the 2 that's in the denominator and then the 3 and 3/10. Again, matching the corresponding heights that are up. So this is going to get me my scale factor. We'll divide that into the calculator, 1 and 65/100ths. Hello, scale factor. Now, we want to write an equation that's going to relate the vertical height. So if the height of this is 1 and 1/10 and it's 1 and 65/100 is my scale factor, there is my equation that relates them. All right. So when we do that, we get 1 and 815,000 centimeters. That is a decimal that is there. That would be the other vertical distance that we've got going on here. To explain how the equation illustrates relationship, so what they're really kind of asking, what you're really doing here is this. You're doing more of a y is 165/100ths of the x. So when you plug in the x, which is the initial amount, all right, you multiply it together like we did right there. So again, I'm not as interested in that. That's a little formal. That's not our push right now. The big push is that you could figure out the distance and that you could end up figuring out the scale factor. All right. Last one here, and that's it. We got the length of a rectangular prism is 8 inches. So length typically is the one that goes up and down. Wider is what goes left to right. And the picture is reduced to 45.5%. So we're going to reduce it by 45.5%. Write an equation. Okay, again, the main thing is if you were formal, the result would be 45.5% times the initial amount. So we're going to kind of clean that up a little bit. A half is 5/10. We're going to go 2 spots to the left to change your percent to a decimal. So there's your official equation. Again, they're trying to relate a lot of what we've seen before. The main thing is you're finding the percent of it, so you're multiplying. Either way, it's going to work, but again, that's just the formal look at it. So if it's 8, that's what you're going to plug in. The y is the result. So again, we just went a little more formal. I'm not going to ask you to be this formal. I'm more interested in could you get to this of what we're looking at. So that would be inches that we've got. They do want to write an equation, so technically I did that. Relates to the lengths of the pictures. All right, that's fine. Really what we're doing is we're finding 45.5% of something. That's why it's your multiplication problem. So that's it for now. If we kind of look, oh, that's lesson 15. So we're going to stop ourselves right there. We are done.